You're on candid camera.
Sweet.
There we go. All right, let's talk about the agenda today of the stuff that I want to talk about. And we won't necessarily be able to get to all of it, but should be able to get through most of it and at least start the last topic, which is a big one, as they say. The topics that I want to cover are as follows. Like I just forgot what they are. No. Are conditional statements or if statements, loops, functions, and then the big one, objects and classes. We certainly won't say everything that we're going to say about objects and classes today, because really that's the next 14 weeks probably. All right, so we will probably introduce that notion to you and talk a little bit about it, but we're going to go over that in a lot of detail. So I do want to get through those other three things. Those are the sort of the basic building blocks of any programming language. Last time we went over sequential statements, I think, and arrays and variables and that sort of thing, foundation kind of things. And I want to cover these. And I want to cover these from the perspective of just reiterating what they are in general. And secondly, how you do it in Java, just to give you that introduction. So that'll give us sort of a good introduction, and we can then really dive into classes and objects, our next big topic. In really a big way. A few things, it's really tough thinking of examples sometimes that are not like too complex or too simple. So bear with me if the examples don't seem realistic. I mean, it's doubtful that anyone would write an application to convert Fahrenheit to centigrade or to figure out how many scoops of iced tea you put in a pitcher or anything like that. All right, but they're meant to illustrate a point, you know. I don't want to overwhelm by going over a mammoth example. The idea is that the concepts come through even in these simple examples. The other thing that we're going to do is we're going to behave ourselves, all right, from the perspective of we're not going to throw error conditions at our code as of yet. All right, which is pretty easy to do because we don't have a GUI, right? We're hard coding everything. So we're going to behave ourselves, and we're not going to try and do anything that's not legal. You know, do some condition that would cause us to divide by 0 or something like that. Obviously, well-written programs need to address that. We haven't covered it yet, so we'll save that bit until later. All right. So the example we had last time was to do conversions between Fahrenheit and centigrade. And where we left off last time was something like this, where we had our code. We had a class that was just sort of our playing around class. We declared a couple variables. That's what this indicates. Double means that there's decimals involved. Int is an integer. These are primitives. We know that at a glance because it's lowercase. So the D in double is lowercase. The I in integer is lowercase. So we know that those are primitives. The other sign that this is a primitive, we'll talk about later when we talk about classes and objects. But we don't say equals new something or other. And we'll do that when we do objects. Here's our array. All right. And here's a calculation to set or randomly choose. Actually, that comment is incorrect. Randomly set the temperature in Fahrenheit, do the conversion, then display the results. We do it again, display the results, and so on. Now, if you notice, that's repetitive code. We're doing the same thing each time. All right. We have an array of values here. So the first thing we're going to do is we're going to put a loop in our code, instead of duplicating a block of code 3 times or 5 times or whatever, we're going to do it so it will iterate through the loop and do it once for each element in the array. All right? Essentially, if you will, this array of temperatures are sort of our test cases. All right? The class that we're creating here really is used, and the values we're hard coding are sort of like test cases that we're testing. And we should test a range of things. If I was testing this, I would include, the freezing point, the boiling point, maybe a point below the freezing point, a point between the freezing and boiling point, and maybe a point above the boiling point, just to really thoroughly test it. I want to make a point to talk about testing throughout this term, because that's one thing that, in my experience, even fairly experienced programmers don't necessarily do a great job at. Some do it better than others, but a lot of times testing constitutes, we'll run it a few times, put some values in, see if it works. All right? It's better to have take a much more systematic approach, and identify different test cases. And really, in our main function, really largely what we're doing is we're going to be, in future assignments anyhow, we're going to be building some test cases and running our classes through these test cases. And once we find that they work, then we can do other things with them. Maybe we can hook them up to a GUI or whatever. All right, so the first thing I'm going to do is I'm going to set up a loop. And there's a couple of different loops. We'll just look at one of them. And it's sort of the classic one that you use to loop through elements of an array. And the way it works is something like this. For, and you have a parenthesis that specify the parameters of the loop. All right? You have typically a loop index. And, yes? Oh, okay. Yeah, do you want to hit your thingy? All right, thanks. This is sort of like the loop index. And typically, if you're looping through an array, remember the array starts with element 0 in the array. So if we want to look at the first element, we're going to start our array counter at 0. So that's our variable for our array. We're setting it to 0 initially. We then have a semicolon. And we'll say I less than some value. In this case, I'm picking a value of 10. What that is if this condition is true, it does another iteration through the loop. Lastly, we have the increment, where we're going to increment the variable I by some value. And in this case, we're incrementing I by 1. So this loop is going to, the first time through, I is going to have a value of 0. I is going to have a value of 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to hit 9. It's going to go up, increment it one more time, giving a value of 10. Since 10 is not less than 10, it will jump out of the loop. So if we were to have something like this, print system out println I, and then do the same thing here, it would show 0 through 9 from inside the array, and then immediately afterwards the print would show a value of 10 for it. All right? Now what does this, yes?
Does the variable still exist outside?
It depends on where you declare it. Yeah, it depends on where you declare it. All right. Now, if we're iterating through an array, we want this to equal the number of elements in the array. All right? So if there's 5 elements in the array, we want that to be 5. If there's 20, we want it to be 20. Now we could hard code that value, or we can use whatever the name of the array is, dot length, if we spell it right, all right, to indicate that. So let's go, and I'm going to take out the 3 hard-coded things that I have in this, and I'm going to include the statements in a loop, so we'll iterate through the values in my array. So let's go here. And I'll do this. Whoops. Something like this. And I will say, no, I won't. I will say for I equals 0. So the initial value for I is going to be 0. I less than temps.length. All right. Temps is the name of my array. Length is the number of elements in it, so that would be 3. I could hard code 3, but that wouldn't be quite as good as saying that, because then if I added or removed an element from that array, I'd have to go and change that value here. All right. Programming is largely a case of inspired laziness, right? We think and we do things cleverly so that if we have to change it in the future, we don't have as much work. So I could put 3 here, but then if I added an element to the array, I'd have to remember to go and change that there. And again, that's 2 things I'd have to do as opposed to 1. I++ is simply shorthand for I equals I plus 1, or increment I by 1. Again, I use the braces to indicate containment or grouping of statements together. So if we look, and again, all the braces are pretty well lined up, right? The brace at the start of the class is closed down here. The brace at the start of the function is closed here, and the brace at the start of the loop is closed here. So let's go compile this, and hope I didn't make any typos. Oh, I didn't make any typos, but I should do that. I want the ith element. So the first time through will be element 0, second time element 1, third time element 2. All right, let's go and save this and compile it. Thinking about it? All right. And then we can go and execute this. And if you notice, it iterated through the 3 different things in the array. It said 10 Fahrenheit is negative 12 and change. 37 Fahrenheit is 2 and change. 180 degrees Fahrenheit is 82 and change, which corresponds to these 3 elements in the array. I would assume this is largely review. If you've done any programming before, you've done loops, so I would assume really the difference might be the syntax of this. Although most languages have loops similar to this, very similar to this. All right. Questions about this? Yes?
If you didn't declare out before you got into the loop, you would have to declare it before state.
Yeah, what you could do is you can do this as a shortcut. You could say for int I. All right? And that way, if you're only using it for, if that's the sole purpose of this, to be the index of the loop, then yeah, you can do that, and it's there. If you do that, I don't think it would be available here, which was getting to your question.
When you have, like, all of your loops use the same variable name, because it releases that.
You could. How do I want to say this? Let's see. Let's verify that. Let me demonstrate this. Let me put a print after. This should get an error. This should get a compile error. Because, again, that variable only has scope for this instruction, I believe. We'll see that. Sure enough, can't find symbol, doesn't know about I. If, however, I do this, pardon my sloppy code for a second, that's legit, and it will compile. But yeah, I suppose that's an advantage of doing it that way. Is you don't keep that extra variable around, slightly less overhead, probably not that huge of a deal. But yeah, you can then use int I several different times through it. I'm a big believer of doing what you think makes the code most readable. All right, so I do it a certain way, because that's the way that makes it readable for me, and the best thing to do is to find what works for you and do it in a consistent manner. That to me is more important than me to try to define a set of standards that you should do it this way or that way. Hey, if it's easy to understand and you do it consistently, hey, good for you. All right, let's say I want to print out a message that says if it is below 0, that it's cold. Okay, below 0 centigrade, that is, which is below freezing. All right, this will be our conditional statement. All right, so I could do something like this. Again, the statement for that is an if statement. All right. Typically, this is the style which I code them in. You have a condition in here, which is a Boolean, something that evaluates to either true or false. So in this case, if I wanted to say if the centigrade temperature is less than 0, I could say that. If C less than 0. This is a block of the statements that you do if the condition is true. Optionally, you have an else if the condition is false. All right? And again, you can either have it or not have it, depending on the particular problem that you're working on. And then between here and here are the block of statements. A couple things about this. I'll introduce them now. I don't know if we'll see them in this example or not. But this is one of the prime errors that folks make in Java, is comparing equality. All right? To compare if two values are 0, or two values are equal, Like, for example, if we wanted to compare to see if C was exactly equal to 0, our if statement would look like this, with two equal signs. All right? The equal sign in Java, as really in any programming language, is used for two things, really. It's used for assignment. For example, if I say x equals 5, that's using the equal sign as an assignment. And if I use an equal sign like that, it says take this side of the equal sign and store the value in that variable. All right? Pretty standard in any programming language. Comparisons, though, are a different thing. So this is saying, hey, set this variable equal to that. This is asking a question. Does this variable equal to that? And in Java and many other languages, the double equal sign is used to indicate a comparison. So very often you will say, if you were to forget that, if your if statement doesn't seem like it's having any effect, it's always turning out to be true or false, check and make sure you don't have double equal signs. All right? VB gets around that just sort of by context. VB sort of figures out what you mean. And again, in Java, you can explicitly do it. And you explicitly specify, do you mean a comparison or a assignment? All right? So let's go and implement this code. And I'll do something like this. And I'll say if C is less than 0, something like this. I should vary how many O's there are in cold depending on exactly how cold it is. The colder it is, the more O's are in it. But we'll save that for another day. All right, let's compile this guy and let's run it. And again, tells me that negative 12 Celsius is cold. The other two, it doesn't display the if statement. If I had an else, it would go like this. I would just say underneath it, else, and then have my brackets there for that. Yes?
Does Java ever use the triple equal sign?
Repeat that, please.
Does Java ever utilize triple equal sign?
Does Java ever utilize a triple equal sign? That is a good question. I do not believe so. You're talking about like in PHP? Yeah. I don't think so because the difference between Java and PHP is PHP is a weakly defined, the variables are weakly typed. All right. So therefore, a string with the word true in it, you run into confusion if you compare that to a Boolean variable that's true or false, right? Because in some respects they're the same, in some respects they're not. So in PHP you get around that by saying, with the 3 equals, does it match and is the data the same type? Given that Java is strongly typed, there's probably no need for a triple equal. So I've never seen it. To be frank, the triple equal sign in PHP was kind of a new one on me. All right, but I've never seen it in Java. So, but just sort of logicking it through, I don't think it would really be necessary given the fact that everything is declared with a type. All right. Other questions? All right. The last thing we're going to do before we hit our big topic of classes and objects is to move this code into a function. And there's really 2 reasons to put code in a function. All right? Two reasons I can think of. First reason is sort of a divide and conquer mentality. All right? In other words, a big problem oftentimes is just a bunch of little problems. And sometimes if you look at the big problem, it can seem overwhelming until you sit down and break it down into some smaller steps. And I'll give you an example that isn't really related to programming, but it is in the tech world. I'm not really a hardware guy, and I had to I wanted to try replacing the fan in my laptop. All right? For someone that's a hardware guy, probably a short job, right? For me, I was a little apprehensive with that. All right? I found a good guide online. And what it did is it walked you through each step. I have a MacBook, so it said, here's the step for removing the battery. Here's what you have to do to remove the battery. All right, I kind of know that one, right? I got that one down. That one's not that bad. Here's the step to how to remove the hard drive, okay? Here's the steps you need to do to remove the optical drive. Here's the steps you need to do to remove the case, and so on. So it had a section for each one of these tasks. And then when I looked to say, hey, to remove the fan, what do I have to do? It showed me the list of steps I had to do. So I had to first remove the battery, then remove the hard drive, then remove the case, and then so on. Now, if I would have seen all those instructions, everything I had to do to remove the fan, I probably would have ran out of the room screaming. But they broke it down into simple little tasks, and somehow it didn't seem as intimidating. I mean, divide and conquer. Take a big problem and break it down into smaller problems. Now, there's a lot of advantages for that. For one thing, sometimes it can be overwhelming to try to look at a big problem, but if you take and do a little piece of it at a time, it is doable. It's good as far as testing goes, right? Now we'll get back into software, for example. If you were writing, say, an application to calculate payroll, where you calculate the gross pay, calculate overtime pay, calculate Social Security, federal withholding, city withholding, health insurance withholding, blah, 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 blah. here's your net pay. You could fake out and just put a what we called in the old days a stub function for federal tax. You know, hey, I'm not going to really calculate the federal withholding tax. I'm just going to assume it's $200. You know, that way I can test the rest of the code. You know, and it's not right, but I don't have to worry about all the details right this minute. I can test portions of my code before the whole thing is done. All right. It's good, I think, from an attitude perspective. It's better to get part of a problem done than to be sitting in a sea of code where nothing works. All right. Different people can be assigned to different parts of it. You know, there's a lot of advantages to it. So there's that reason, sort of the divide and conquer mentality. It makes doing a bigger task easier if you can break it down. Second advantage is reusability, all right, and maintainability. For example, in this case, we have the calculation for doing Fahrenheit to centigrade, all right. If we had another program, or if we had a different section of this program, let's say, if it was a bigger program, we'd have to repeat that calculation there again, because our calculation for Fahrenheit to centigrade is embedded in the middle of this main routine. So maybe if somewhere later on down the line we had to do the calculation again, let's pretend, all right, we'd have to duplicate that calculation. All right? Well, what does that mean? Well, what if we got a bug in it? What if instead of multiplying by 5/9, we multiply by 5/8, for example? Or it's not really relevant for centigrade to Fahrenheit, but what if something about the calculation changed? You know, let's say if you're doing a payroll thing and the rules for tax withholding changed. If you have that snippet of code in several places, you're going to have to change it in several places. Well, what's going to happen? You're going to do it right sometimes, wrong the other time, and you'll end up with inconsistency. So it's best to have your code in one place, functionality in one place. So objects and classes are sort of the next step on this path, but before we talk about them, I want to review functions with you. All right, make sure you really understand them. It's my experience that it takes students a few times to go through and really get functions. And maybe you folks all have them, in which case the review will go quickly and smoothly and won't be an issue, but maybe you'll benefit from them. The idea of a function is that you give it some values and the function returns an answer. All right? Now, not all functions are like this, but most of them that we're interested in are going to be like this. We give it some values, we get back an answer. All right? The idea is that the values that you give the function are called arguments, are sort of the parameters of the function, or sort of the values of the ingredients to the function that you're going to use to get the result. For example, if I had a calculate gross pay function, it would take arguments, the hours, and the wage rate. So if I have a calculate gross pay function, that's what you need to calculate gross pay. The hours and the wage rate. And then that function can do its thing. And you know, it can do the calculation, it can calculate overtime, whatever. And then it gives back to you the answer. All right? Few things about a function. All right? Everything that a function needs should be passed into it as an argument. All right? The more that you can do that, the more reusable the function is going to be. All right? The other thing to keep in mind is that functions can return one of something. All right? A function can return an integer, a double, a boolean. All right? Those are probably the more straightforward things. But a function can return, when we get into classes and objects, it can also return an object. All right? But whatever it returns, it can only return one of them. All right? And we'll see the implications of that. Sometimes it's hard for students sort of to give you a preview, to make the leap to functions that instead of returning a integer or a double, return maybe a customer object or something like that. But we'll see examples of that, and we'll build up to that. All right. The way that you declare a function in Java is something like this. We've already declared one function, right, the main function, so we can sort of use that as a template. All right. First thing we're going to do is we're going to make it public. Not today, but at some point we'll differentiate between public and private and that sort of thing. All right. So we'll make a public function. We're not going to put static in here. Or actually, in this example, we are going to put static in here. All right. My mistake. That's a mistake I've made, I think, every semester on the first example in Java, which I should go back and count how many semesters I've taught Java, because then I'll know, how many times it takes to get something sunk into my head. All right? So for this example, we're going to say public static, and we'll talk more about static functions later on. We then specify the return value. If we look at our main function, we have public, static, void. And void simply means that the function doesn't return something. All right? And you can have a function that doesn't return something. It does something, but it doesn't return a value. And that's an example, our main function. In this case, our Fahrenheit to centigrade function is going to return a double. All right? We can then give our function a name. Convert temperature, convert temp, using the convention of the first letter of the first word being lowercase, the first letter of each subsequent word being uppercase. And then we specify the arguments and the type of argument that we're giving. When we specify the argument, we need to include both the name of the argument and the data type for it. So in our case, what do we need to do to convert the temperature from Fahrenheit to centigrade? What does this function need? It needs the temperature in Fahrenheit. So I'm going to say double arg f. Let me zoom in on this. I don't know if you can see that real well. Public means it can be accessed from any classes. We'll talk more about that later. Static means it doesn't require an object to call this function. All right. These two we'll talk more later. Double indicates the return type. This is what it's going to return. Convert temp is the name of the function. And enclosed in parentheses are the argument or arguments. In this case, there's one argument that's called argf, and it's a double. All right? By convention, I typically call my arguments arg something or other. All right? It just helps keep me straight that, hey, this is an argument that got passed into it. Again, I sort of gave my view on programming practices. Find a convention, find something that works for you and makes the code easy for you to understand, and then be consistent in implementing it. All right. So, this, by the way, is sometimes called the signature of the function, because it really tells you just about everything you need to know about this function in order to use it. All right? To use this convert temperature, I need to give it an argument that's a double, and I'm going to get back a double. All right? Ideally, that's how all functions should work. The term that they use sometimes, borrowed from engineering, is a black box. You know what you put in, you know what you get out. What happens in between, really, people that use this function don't really need to know. All right? A well-written function you can use without knowing the details of what goes on inside of it. Case in point, What does the code look like for this function? That's a function, system.out.println. I don't know. Did it affect me using it? Nope, because it's a well-written function. I give it its arguments, it does its thing. All right, so let's go and let's create the function in here. And I'll go here and I'll say public static double convert temp, and it accepts as an argument a double, and I'm calling that argf. That's the name of the argument. Argf is sort of a placeholder. It's where we're going to, how we're going to refer to the value that gets passed into it. Because we don't know what value you're going to pass into it. You could pass anything into it. So argf is sort of like a placeholder name. So whatever we pass into this function, we're going to refer to it within the function as argf. So I can do something like this, and I can say double result. My result equals, hey, whatever argument I passed in, minus 32 times 5 divided by 9. And then when I'm done, I can return the result. Now, I'm not going to lie and say I did this on purpose, but if you notice I hesitated there. All right? Why did I hesitate? I hesitated because these curly brackets look funny, right? Actually, this curly bracket belongs to that function. So therefore, this should be up here to close that function before we start a new function. Now, again, didn't do that on purpose, but never would have seen that if I didn't align those curly brackets right. All right? Just at a glance, you see that something's wrong. I saw the extra bracket at the end. It's like, that doesn't add up. All right? Now, I'm going to change this code to say, instead of having the logic built into it, I'm going to say, hey, C equals convert temp, and I'm going to pass it the value of f. So, as we loop through this array, each trip through the array, f takes on one of these values. We call this function, give it that value, so argf has those values of the array in turn. We do our calculation, we get our result, and then we return the result. Whatever value gets returned gets stuck into that variable. All right? Now, we can't access the variable result up here. That variable was declared within the function, so it's only accessible within that function. However, we can take the return value from that function and put it in this variable. All right? And now we should be all set. Still works the same. The outside of it, you know, the results of it aren't any different. But now our code's a little bit better because it's more maintainable. And if we had to call that function elsewhere in our program, we'd have the ability to do that. Questions about these functions? Make sure you understand functions and arguments and return values and how they work. That's a huge deal as far as this class goes. All right. Questions on any of the stuff we went so far? We have about 10 minutes left, and I'm going to spend those 10 minutes, all right, talking about objects and classes, or classes and objects. And again, you better, you know, this is a topic I can kind of easily get wrapped up in, so maybe someone will need to shut the mic off at 10 till and drag me out of the room kicking and screaming, because it is an interesting topic and it's an important topic. So But again, I do want to introduce it today. Does anyone have a definition or a description based on maybe programming you've done before on a class, object, the difference between the two, what each of them are, and so on? Yes? Object is an instance of the class. What's another way to say that? Yes? Yeah. Class is like a blueprint for an object, or a class is a template for an object, and an object is a member of that class. All right? What is a class then? We said it's, we're sort of getting into a circular definition of these things. Let's back up a little bit and let's talk about what a class is. Yes.
The collection of variables and functions.
Okay. The statement was it's a collection of variables and functions. That's true. Does anyone want to add to that? Yeah. Methods and properties are another way to say variables and functions. Actually, methods is another way to say functions. Properties is another way to say variables. All right. A class is a generic, is a software model of some entity. And in this case, we'll talk about real-world entities, but they can be more vague and conceptual sort of entities. But let's say, for example, let's talk about a student class. That's a software representation of a student. All right. What does that mean? All right. It means that it has all the relevant characteristics of a student. And by relevant, I mean relevant to the particular problem we're trying to solve. All right? For example, what are some characteristics that every student has? Student ID number. All right? Every student has a student ID number. So our template for student will have a student ID number. All right? What's another characteristic?
Gender.
The gender. All right? Another characteristic. Name. Address. GPA. All right, birth date. Every student we know has those characteristics. So our template that we build for students has those characteristics built into it. All right? Now, an object then would be what? Would be a member of that group. So a particular student would be an object in this model. So I can ask a particular student, what's your name? What's your GPA? What's your major? What's your address? What's your phone number? And that student should be able to give me an answer. So a class is a software representation of some entity, but again, not a specific member of that entity, but just the entity as a whole. An object is a particular member of that class, is a particular instance of that entity, and has values for those particular things. Now, in the textbook, I think it's this textbook, it talks about a class can know things and do things. All right? And that's a pretty good definition. I want to extend it a little bit. And when we say a class knows things and can do things, attributes and methods, variables and functions, and so on. The other thing I would say is an object or a class can answer certain kinds of questions. And that may actually be a little gray area if you're talking about an attribute or a method. Typically, though, we're going to align those things with methods. So, attributes for a student. what are things that a student would know? A student would know their ID number, a student would know their name, a student would be able to know their address and phone number. What are some actions that a student is involved in? All right. I guess another way to say this is, run out of space here, characteristics and actions. What are some actions students are involved in? Students are involved in enrolling in classes. Students are involved in withdrawing from classes. Students earn degrees. Students get grades, and so on and so forth, or assign grades. Students declare a major. There's a lot of activities that students are involved in. All right? In addition, beyond knowing things about themselves, students can answer questions that might involve some sort of calculation, like, what is your GPA? All right? Usually when you think of attributes, you think of just a simple characteristic, but there are some things that kind of look like attributes in that they're a characteristic, but they're actually derived because you sort of calculate them. All right? And that's an example of that would be like, what's your GPA? How many miles do you drive to get to school? All right? Those can be calculated based on different attributes in that. All right, we're going to do a real simple class, and I'll just define it now. And I don't know how far we'll get. We have a few minutes left, and we'll pick up on this one Monday. But again, it might be a silly example, but it's hard to make an example that is really good and not too complicated. So, I typically bring a little jug of iced tea with me. All right. So we're going to write a class for pitchers of iced tea. All right. Now, let's talk about what my pitcher knows and what my pitcher can do and answer about itself. I have a pitcher in my refrigerator right now. Conceptually, the notion of a pitcher is a class. That specific pitcher in my refrigerator, all right, is an instance, a member of that class, and therefore is an object. All right, so my class is going to be pitcher. All right. What are some of the things that this pitcher has? Yes.
Volume.
Oh yeah, a capacity, a volume. And I'm going to make a note that this is going to be expressed in ounces. And we're going to make this a double. All right? Double volume. All right? Now, when I go to make a pitcher of iced tea, I have to know how many scoops of the iced tea mix to put in it. All right? And the rule is that 1 scoop per 16 ounces of water. So, a question that my iced tea pitcher should be able to answer. I'm sure glad the door is closed and I have all software students in here, because if someone was walking by and I was talking about my iced tea pitcher answering questions for me, I don't know, that might be hard to explain. But a question that my iced tea pitcher class or object should be able to answer is, how many scoops do you need to make a pitcher? All right? And so we'll say how many scoops, and that will also be a double, right? Because it could be, if it was a weird size pitcher, it could be 2.5 scoops or whatever. The other question that my pitcher should be able to answer is, how many servings? Given that we're going to consider 8 ounce per serving. So, notice that I'm not keeping track of what the pitcher is made out of, right? Why not? It's not relevant to the problem I'm trying to solve. If I was calculating how much, maybe how many pitchers I need, if I have 10 people coming over. Or maybe if I have a 2-quart pitcher, how many scoops I need and how many people I can, doesn't matter if it's a glass pitcher or a plastic pitcher. So these things that I'm describing this class in, I'm limiting to what's relevant to the problem domain. Okay? For example, going back to the student. If you think about that, all students have a height, right? But would that likely be an attribute in the student class? No, because as a student, it really doesn't matter how tall you are. All right. Now, your birth date might matter, right? There are rules for students that are under 18 to come here, and so on. So that may be relevant, but your height isn't relevant, so it's not an attribute. Now, here's the interesting thing. And we'll come back to this next time, and I always wish we had 20 more minutes. I know you guys are, no. But one thing we're going to do, this is sort of the cliffhanger that I want you to think about next time. This is where we'll start class next time. These 3 things, attributes, methods, or what? All right? Are these things really characteristics of the pitcher? Which case they'll be an attribute? Are these sort of questions that the pitcher can sort of answer and calculate? So let's think about that, and that's where we'll pick up next time. And then we'll actually go and create this class and run some tests on this class. All right. We'll see you up in lab.